ahead and start while people can keep on hopping in. So, hello everyone, welcome to the Career Advancement webinar organized by EPSI. My name is Jaiti Chhabra. I'm the chair for this EPSI committee and also one of the directors for IBPSA-USA and your host for today. So just to give you a basic background, EPSI is Emerging Professionals and Students of IBPSA-USA. It is a committee started to address the needs of those who have less than 5 years of experience in the building simulation industry. So if you are not a part of this yet, feel free to register. There will be a link posted by the EPSI team in the chat soon. Also, if you are experienced and you want to become a mentor for this group, feel free to reach out to me or send a message at epsi@ibipsa.us. Displayed on your screen. So, all right, without wasting any more time, let's start this session. And if you get any questions during the session, do post them in the Q&A section. We will definitely take them towards the end. All right, so today's topic is tool and software development, specifically in building simulation industry. Now, when you think of a programming tool or a software or a web app, immediately I think of computer engineering, coding comes to my mind. However, in various fields, specifically building performance, we have often seen mechanical engineers, architects, and consultants stepping in, creating workflows to speed up analysis that you can quickly run on a building and make informed decisions. And with climate change pushing us to make our building sector decarbonized and energy efficient, I know that various individuals have broken the boundaries of knowing only their industry-specific knowledge and have tried to extend their automated workflows for everyone to use. So if you are one of those who want to contribute to the automated workflows to have a bigger impact, or just want to know more, you're in the right place, because we do have these three exceptional individuals with us today who will talk about tool and software development from all kinds of perspectives, whether it's from a student side, architectural background, or engineering. So welcome, Kritika, Neal, and Kruis. Let's go ahead and start with some introductions here. So, Kruis, do you want to go ahead and start?
Sure. Yeah. Thank you, JT. I'm Kruis. I'm a co-founder of Ladybug Tools, and I've been working on the Ladybug Tools project for almost 10 years now. I guess we had our very first release way back in 2013. But for most of those years, about 6 or 7 of those years, it was mostly just a hobby project that ended up becoming very popular, such that today the software has been downloaded over 500,000 times. And this was beyond either my co-founder Mustafa and I's expectations about where we'd eventually get to. But as of 3 years ago, we've started a company around Ladybug Tools. The core of our software is all open source and free, as is our grasshopper plugin. But we've now started to offer a few other products and services around Ladybug Tools, specifically a Rhino plugin that allows you to not need knowledge of Grasshopper. We have a Revit plugin, and we have a cloud service that we're starting to sell and ramp up our sales for. So that's generally what my pathway has been through my career. When I first started Ladybug Tools, I was a student at MIT, a master's student, and I have about 3 years of experience working at an architecture practice. So I'm happy to provide the architecture background, as you mentioned, JT. So
awesome.
Thank you.
Yeah, welcome. And as we were discussing, and I was asking Kritika not to steal my comment, that you should know that we have been completing our schooling, watching your videos. So some of us can even mimic you respectfully, like, hey, it's Chris Mackey. And, if we hear it from a distance, we can definitely know that what video they're watching.
Yeah,
All
I hear
right.
a lot of people tell me my voice sounds familiar from the videos.
Amazing. Neal, do you want to go next?
Sure. Yeah, so my name is Neal Kruis. I am the Vice President of Big Ladder Software in Denver, Colorado. I've been working at Big Ladder for a little more than 10 years now. I have a PhD in architectural engineering from the University of Colorado in Boulder. And before Big Ladder, I was developing software at NREL, working on tools like BOpt and Energy Plus. And I still work on Energy Plus at Big Ladder, but now I've kind of expanded that to work on other tools like the California Simulation Engine. Our Big Ladder's product is called Model Kit. And then a lot of C++ libraries that kind of work behind the scenes and maybe some of the software that you use. Kiva was part of my PhD dissertation, which calculates foundation heat loss from buildings. Penumbra is a library that calculates solar shading using the GPU. And more recently, a toolkit for adding ASHRAE standard 205 HVAC performance data, reading, writing capabilities to software. So that's something kind of new and coming up. The software I typically work on is kind of deep in the software stack, kind of the tools behind the tools. Most of the time it's C++ or Python, but some of the other projects are in Ruby or doing some level of web development. I've always had a hard time explaining to people kind of what it is I do, because I'm a software developer, but I'm also a mechanical engineer. I have a degree in architectural engineering, but I'm also a building scientist. Sometimes I like to say I'm a computational building scientist, or simply sometimes I just say I develop software to help design less carbon intensive buildings.
Yeah, I was amazed when you agreed to be a part, because EPSI is new and having a vice president of Big Ladder is a big deal. I know, Energy Plus, Open Studio, there's like so much involved that Big Ladder has been a part of. So we're really glad to have you.
Thanks, Jenny.
All right, so Kritika.
Yep, thank you. Hello, everyone. I'm Kritika Kharbanda. I'm currently a graduate student at Harvard Graduate School of Design, specializing in energy and environments. I graduate next semester. I'm currently also working as a research assistant with Professor Holly Samuelson on a project funded by the Google Data Commons, where we are looking at retrofitting energy scenarios for residential buildings, looking at future grid conditions. Apart from that, I'm also an Adrian Cheng Fellow at the Harvard Kennedy School, where I'm working on breaking the digital silos in the building industry. So exactly what all of us are doing here. And before coming to the GSD, I was working for almost 3 years as a sustainability specialist at Henning Larsen Architects in Denmark. So I've been an architect and now moving more into the engineering or consultancy side of things. And yeah, happy to be here. Thank you.
Awesome. I have been impressed when I saw Cardinal LCA going out, and you have so many more tools to come. So we will be definitely talking about it, but you should know you are doing really well as a student.
Thank you. I mean, as a student, you don't know what you're doing. So I'm exactly at that point.
All right. So on that note, we are going to start from you first, because we want to start knowing from the base root, when you are a student, what exactly motivates your aim to digitize this building industry? Or what do you think is the importance of tools in building performance industry today?
I feel for me, when I started practicing architecture in India, and then when I moved to Denmark for first an internship, I felt this big change in how the workflow differed from in both the offices. And I felt that there were so many things that were more automated and saved so much time and resources in terms of like both money, but also people, that offices in Denmark were following, not just in terms of sustainability, but also, let's say, general things like, I don't know, moving from mesh to a surface or whatever. And that was when I felt that there is so much time and resources that we can save if we just spend some time automating some workflows in our daily lives, and it just makes all our jobs easier. So that was when I realized that we need to be more digital. Like in my bachelor school, we weren't even allowed to use digital softwares until our 4th year. And I say you resonate with that
Definitely.
feeling. And that sucks because that's all you use in an architecture office. And you don't do that for the first 3 years of your education, which is so weird. So for me, just understanding where the problems lie and where exactly can we make a change was the incentive behind making these digital tools.
Right. And you have mentioned how it speeds up the process. And as a student, you understand the aim, but I think we have talked about how your project assignments have turned into these tools. So is it a usual requirement of that assignment, or is it just you? And what is the basic usual workflow you follow when you're creating or starting to create a software?
Sure. So it's not a requirement at all. And for me, I first understood what kind of things were needed in, like, I was lucky because I had worked in the industry for a while and then came to graduate school. So I kind of had an intuition on what is selling and what is not, and what exactly do you need, where do you want to make a difference. So that is the like the niche or the subject I went towards, taking courses on that kind of topics. And then I tried to find people who were like-minded, who wanted to work on, let's say, the same topics. And then also trying to understand what kind of skill set I needed. So before coming to GSD, I had limited background in coding. Like I just knew Grasshopper, watching Chris's tutorials and following all the like the plugins which were there. So I was just basically making scripts. But then I started taking more courses in C# and Python. And now I think I'm like I won't call myself a data scientist, but I'm getting better at it with every semester. And I feel that these are the skills which are so required. But even if you don't have it or you're not interested to learn these, you should partner with someone who has them and then try to move towards your goal. So that was like the initial first steps towards any project. And then there are several more, but we can discuss them later.
Yeah, definitely. And that I was coming to my next question, that is there something you are working on currently, or what are your biggest focus areas for your future development? So if you have an example, feel free to show it as well.
Sure. So as Jayati mentioned before, I was working on a tool called Cardinal LCA. It was a plugin, again, born out of a semester project. It was essentially a Grasshopper script, which turned into a set of plugins, just like Ladybug. For now, we are not working on it further, but I am right now working on essentially an assembly analyzer tool, wherein I'm partnering with architecture firms and asking them to share their as-built external wall assembly data, anonymizing it, analyzing it, and then feeding it into a regression model process, and basically helping other architects who are new to, let's say, a particular building type or a particular climate zone understand what kind of materials can they go for, what kind of thickness. So let me just quickly share my screen to show this tool. So yeah, right now it's called Assembly Performance Analyzer Tool, again, a semester project. So we collected several assemblies with from 5 architecture firms, categorized them into different types, like based on their location, so window wall, curtain wall, and based on the carbon footprint. Now you can go inside the database and select a particular assembly if you're pretty sure of what you want to look at. And we are using this 3D heat map kind of scenario to understand where exactly does the carbon lie. If you look at a typical scenario of 1 by 1 square meter cross section, and you can see that maybe the insulation is not performing too well. And for now, we are looking only at the carbon footprint, so the product stages A1 to A3, but the future aim is to also look at the, let's say, the heat transfer and the cost, because of course, it's not just one criteria that an architect looks at. So one other thing that we aim to do, again, like I know I have Kruis and Neal here who are experts, so it's just a prototype, don't hold it against me. The aim is to also have like a machine learning side of it. So if you are an architect and if you have, let's say, a suggestion from your consultant to go for this kind of thickness and a certain R value, what carbon footprint would you end up having? This is just like an indication of what exactly is possible. Now you can go in and scale it up. And let's say if you have a typical floor plan for a residential building, you can end up selecting different assembly types for all of these areas. And then basically this tool will help you predict what kind of carbon footprint would you have. So this is something that I'm working on. I'm actively looking for more people. This project is funded by the Kennedy School. I have funding, so putting it out there. So please join in if you're interested, or if you have any resources that can help me. Yeah, anything.
Sounds good. That was really interesting to see. And from this, I want to skip to jump to Chris Mackey. Chris, do you have the same, like you mentioned how you started off, but do you also have some kind of experience on how you actually got into tool development? Was it something you were interested in from the start?
I mean, so I should say somewhat similar to Kritika. Like when I first started working on Ladybug tools, and when Mustafa did the very first release of Ladybug in start of 2013, I didn't know any programming language at all. I didn't have any experience in software development. I had just, kind of gotten Grasshopper under my belt. And honestly, I think I could still say to this day, I don't think I've ever taken a course in computer science or programming. That I think I learned it all pretty much by watching other people's YouTube videos. So where I get I got bitten by the YouTube bug, which is part of what inspired me to make a lot of my YouTube videos too. But yeah, by doing that, by just trying to get things to work on projects, and by gradually building up your skill set. And when you get stuck, right, you just search on the forum, right, you find your community that has the answer for it. So that's, yeah, I mean, I got into it mostly after I saw Mustafa made that first release, and I kind of got a sense for the first time that there was no real limit to what I could model, because I always felt like, and I get this question from a lot of people all the time, is like, can the software do this? Can the software do that? And like, a lot of the times the real answer, if you know how to do some programming, is like the software can do anything. You can model anything you want. It's just a question of like, how much time do you have to to learn it and put that together. And so I think that's really what inspired me to get into software development. It inspired me to work on Ladybug tools and start contributing a lot. And yeah, and within those first 2 years of the Ladybug release, I had become the biggest contributor along with Mustafa to the project. And so yeah, so I mean, so definitely I think, yeah, those are three critical things, that if you have just projects that motivate you, like some sort of reference, like a video tutorial series, and a community to ask questions to, you can really you can make it pretty quickly into the territory of software development and tool development.
So if Mustafa didn't post that, or didn't release the first version, what do you think you would be doing right now?
Yeah, probably something different. I mean, yeah, the same thing could be said, like, what if Ladybug tools just didn't get nearly as popular as it was, as it grew to be. I mean, it's kind of hard to say, but yeah, I'd probably still be, I mean, I did a lot of work in architecture offices. I'd probably still be doing a lot of modeling, I think, but yeah, but I wouldn't, maybe have not nearly the skill set I have in software development that I have today. Or, I mean, yeah, I think maybe I would have eventually gotten over the hurdle of knowing that, you still can model anything if you're motivated enough, but it would have taken me certainly a lot longer to get there.
Right. So when you actually, when Mustafa actually released the version, and I'm hoping you would know as well, was it posted on Food for Rhino in the beginning, or was it after you joined? And how did you promote it further?
Yeah, that's a good question. Actually, when it was first published, there was no Food for Rhino at the time. Like Grasshopper was something brand new. Like David Rutten, the author of that, it was still like, he made components to like get, your latest cat memes, and it was like very experimental, I guess is what. So yeah, at first we were just sharing things through like Dropbox, and then Food for Rhino came to being, and we did, we realized all the other projects were posting there, so we put it on Food for Rhino. But if I have to say honestly, like the place where you publish your software is really just the tip of the iceberg. There's no guarantee if you publish your software, even in the right place where everyone's downloading stuff from, that it's going to become popular or well used. And I think most of what I'd have to thank for Ladybug tools, like growing in popularity in the community going around it had more to do with things like, I mean, the videos, video tutorials that we made freely that you guys referenced earlier, and especially our online forum I mean, we've always had a very, very active forum that has continued to grow. I think at this point, you know, we get like 6,000 page views per day and at least like, you know, 25 topics per day, so like 1 per hour or so. And a lot of that is, yeah, that's just, you know, people coming together to help each other around the software. And, you know, I mean, I think largely because of that and largely because people saw, you know, others are using this and others are willing to help each other, you know, figure out certain problems and stuff like that. I think that's what really, you know, created this snowball effect you know, yeah, that it basically the community grew itself at a certain point. We didn't need to promote it, right? It's that people, you know, when you see all these other people using the software, you see other people helping other people, right? It's just going to, you know, grow and grow and grow without necessarily needing any input from us as developers, even beyond like checking the forum a few times a week.
Right. Quite interesting to know that Food for Rhino was not there at that time, because I didn't know that. But would you suggest anyone who has created like a grasshopper script, if there's one of those in the attendees, would you prefer or suggest they post it, like go that route, posting it on Food for Rhino, or do you suggest something else?
Sure. I mean, yeah, the nice thing about Food for Rhino is that, yeah, a lot of other like grasshopper users will be searching there, and Rhino users. So yeah, I mean, I think it's always a good idea to post there, and they, you know, they set up a lot of stuff for you with Food for Rhino, you know, tracking downloads and things like that, you know, that we weren't really doing when we were just using Dropbox and stuff like that. So it's certainly, yeah, it's a great place for Rhino and Grasshopper plugins to publish stuff. Yeah, but I know we have like single click executable installers and stuff like that we distribute from our main website too. So so that, you know, that's also a very valid way. But yeah, especially if you're getting started in Grasshopper, great place to post your plugins to get other people to see them.
Right. And so what does this professional tool ideation look like? Like, how do you decide what, you know, how do you collaborate on these new ideas or choose which items to prioritize now? Because I know it has
Yeah.
been evolving. Ladybug is not what it was like in the first release.
Yeah, and actually, and that question of prioritization is really key, because I mean, yeah, there's really like no limit. I mean, there's no shortage of useful tools that could be built, for sure. And the question of like how to prioritize things is, you know, becomes more and more relevant, I guess, the more that you realize, you know, all the useful stuff that can be made. But I think, you know, one thing, especially now as like a company that we do a lot, is like trying to recognize when, you know, when something is a cool and useful feature that people would want to use, but they're not necessarily willing to like pay us for it yet. Whereas there's, you know, another type of problem where, you know, it's like it is the pain point. People just need this solved, and they're, you know, they're willing to just pay you for it if you have some solution for it or something that saves them time on it. And I think, you know, a good company walks a balance between those two types of things, or a good like software development, because if you spend all of your time just doing the stuff that people are willing to pay you for right now, you're not really going to be doing a lot of the really innovative stuff that will be, you know, is going to ultimately change a lot of the practice and like, you know, and lead to new ways of doing things. Whereas, yeah, if you spend all of your time on like, you know, the innovative stuff that, you know, that people aren't necessarily willing to pay for right now, then you're maybe not able to fund yourself as well, or, you know, or sell products around it. And so, yeah, so it's important to do a little bit of both of these things. And certainly, yeah, I mean, the prioritization isn't constant over time. Like I know for like the year that we're going into now, where we're ramping up a lot of our sales for the first time and switching from being supported by government grants over to sales, that we're going to be doing at least a little more of the stuff that people, you know, solves the immediate pain point that people are willing to pay for right now. But of course, yeah, there's no like shortage. We have a lot of other really important projects that we work on that are just a part of pushing the industry forward or introducing new types of simulation workflows that we, you know, we certainly have a list of those and prioritization for those and the impact that we think that those would have as well. So yeah, if that gives an answer to like how do we prioritize, like I know one of the first things we do is try and like sort the issues into those categories, and then of course, yeah, then, you know, using people's skill sets to try and solve those and build those tools from there is usually then what dictates a lot of the prioritization after that.
Right. Good to know that because it was like a highly requested question from a lot of EPSI members. So moving to Neil from here, because we have kind of covered the student's perspective and, architectural background, but uh, I'm pretty sure we have a lot of engineers here. And I pretty much have the same question, but in a different format that I asked Kritika and Chris. Neil, I know you have been working for, so many years in the industry. So how does your typical workday look like, 10 years ago? And what does it look like now? Because you are the vice president now.
Right. Yeah, 10 years ago is hard to remember actually, but I mean, I just left NREL. I was working on my PhD at the time too. So it was like a split time thing, but I'd say, the biggest difference, like when I first started, was I didn't have many other obligations. So I could work on like one programming project for 100% of a day. Whereas today I would probably say, I may be working on 3 different projects for 50% of a day, and then I spend the rest of my day in like committee meetings or managing employees. And so that's kind of taken over a lot of it, but it's, maintaining those relationships and those connections, that's also important and hopefully can grow from, day one to 10 years later. One thing I'll say is I think something important is even with that expanding responsibilities is trying to maintain, like, even though it's, all adds up to 100%, but the days are not getting longer now that 10 years later, I'm still trying to be very protective of, the time outside of work. So.
Right. Is it difficult to switch jobs when you know that you have a stable job and you're going into, starting a tool or, development of technology that you have not worked on before? Um, how do you feel about that? How should the attendees or the emerging professionals think about it before jumping into?
Yeah. So you like when I moved from NREL to Big Ladder?
Yes.
Yeah. So, I mean, that was a hard decision. NREL is a very large organization, a lot of resources, a lot of stability. And Big Ladder at the time was 3 years old and had 2 employees before me. And so it was a big jump. It was, a lot of uncertainty. I think my situation may be different from others, but for me, I needed a little more flexibility to work on my PhD, and so that was the main kind of driver for me leaving. But Big Ladder offered me that to work part-time, and I think that also works well with a smaller company. That when you're adding a third person, that's 50% more employee, so it's easier if they can kind of have flexibility. And I think a lot of if you have a lot of interest in different things, some of the smaller companies can be more flexible with that kind of things. If you want to work on a degree while trying to learn this stuff or work on this stuff, I mean, that's really what worked for me. I like Chris. Well, Chris said he hadn't taken any classes. I'd taken one class in C++ in undergrad, and it was probably one of my worst grades. And so, going from there to, starting to dabble a little bit more, and it's not just an assignment, it's like an interest, and you get excited about the work you're doing, and to the whole automation piece of it that we've been talking about. When you see, like, you invest that time to get something going, and then you see, like, all right, I can push a button, and then all these tasks that used to take me so long it's just so satisfying, and that drives a lot of, like, the motivation to keep going and try to find innovative solutions to some of these, like, workflow bottlenecks that we all experience. So
Right. And since I know that you have been a part of IBPSA-USA as well as one of the board of directors, what do you think the future of building simulation industry is?
yeah, I think our industry is growing. It's kind of hitting an inflection point. We're growing. People are recognizing the value more of building simulation. We're seeing it adopted more in different building codes. In fact, certain building codes moving away entirely from kind of prescriptive approaches to pretty much you have to do an energy model for almost every building these days. And so I think with that comes a lot of responsibility internally to work on standardization and maybe accreditation. I think accreditation is going to play a huge role in the future of our industry. It's something IBPSA-USA is working on. There's a new certification committee that's looking into, can IBPSA-USA become a national certifying body for software tools, like in terms of like what are the requirements for software tool in terms of like accuracy and capabilities for it to be allowed to be used for some of these more official like building permits or things like that. But also certification for modelers and getting the right qualifications established for who can build an energy model or for an energy model for these purposes, and what kind of training and experience do they need to have. I think for a lot of cases it's almost none right now, and I think I'd like to see that change. I think we all would, because it's going to raise the bar for the work we do. And then the last set of that would be certifying model reviewers, people that it's a pretty thankless job, but looking at models that have been submitted for these things and understanding them, and I think that's going to be a big role as well.
Right. So we see so many tools coming in the industry now. Do you think there's still more space for someone who's thinking of starting their own software company or something like that? Do they still have, is there more scope in the market still?
I think that there is a lot of scope, and part of this growth of our industry, even as Kruis was mentioning, a lot of his funding has moved from like federal grants to now it's more, kind of private sales. And so, we're moving away. A lot of the tools that have been developed with federal funding. And I think that just because there are tools there doesn't mean that any extra effort is redundant. I think that it's exciting to see, oh, here's a new perspective on this thing that we've kind of taken for granted as this is the way it's been done for since the beginning of our industry, really. And so, rethinking some of the stuff that's been there and is behind the scenes, that's something that I get excited about. It's a hard transition to make, but I think excited young people that want to venture into this area, and I think there's a lot of opportunity there.
Right. My last question here before we move further to the next round or so, what kind of skill set would you look for in someone who wants to work in Big Ladder? And I would be forwarding this question to Kruis and Kritika as well after Neal answers, so do think about it.
Yeah. Well, Jadi, you kind of mentioned, like, we all start with some background, and then usually it's not programming, right? And so it's programming is something that we kind of pick up along the way. It's the hardest skill set to find is that combination of computer science and building science. At Big Ladder, we often have to hire someone that has background in one and try to train them in the other, and that's it's an expensive thing to do as a company, especially as a small company. And so if you can start working on that, they're both skill sets that just take a long time to develop too. That's kind of hard, but for my case and others, just taking on a school project, that's a good way to kind of expose yourself and make it necessary for you to like get your feet wet, try something new, and gain some of those skills. And starting from something from scratch versus kind of contributing on the side, I think teaches a lot of lessons about how things are set up, how things will work. And I think that there's a lot of people with that interest of building their resumes with adding programming languages or programming skills. There's one of the biggest things we're seeing these days with applicants is like coding boot camps. There's pros and cons for those, but like there's just a big appetite to bring on that skill set. And I think at the thing that I think makes someone like a good programmer is really just people that are good problem solvers. They know what questions to ask, who to ask those questions to, whether that's Google or Stack Overflow or a Ladybug forum or a textbook, a colleague. Even sometimes you're working on something, you want to understand it so bad that you end up asking the person who wrote the software, and that's so then the last piece of that skill set is, when do you ask these questions to these people? At what point do you go to that whatever extreme to find that answer? And a level of persistence is a good skill as well.
Right. Kruis, I saw one of your interviews where you said that, I didn't have those skills and now I think I have those. Do you want to, answering the question that Neal just answered, along with that, can you also provide some kind of resources that you used or other people can use to get those skills?
Sure. And okay, maybe to answer the question that you fielded to Neal just now, how do you find a good collaborator or or someone that you have a sense would be good at developing software? And I think there's a lot of it actually just has to do with the recognition that you are usually not the first person to encounter a certain problem in software. Chances are that somebody else has encountered it, has at least made some other solution to it. And this sort of willingness, I think, or this mentality of saying, let's just make sure that, someone else hasn't done it first and we can't build on their work first before we go and try and redo it ourselves. Because along those lines, I know you asked what types of problems are really, could we really use as solutions for these days? I know we have a lot of tools available, a lot of there's no shortage of tools that are available that are useful. But honestly, one of the most important things that I think that we've done, or most important philosophies that we have as a company, is that we focused a lot more on just trying to build connections between existing tools and the existing software ecosystem, more so than just trying to introduce another singular tool to solve a problem ourselves. Because honestly, we have, chances are someone has built a really good tool to do something like that. There's just no easy way to get data from one place over to that place, or right. So focusing on basically on building connections between software, on a willingness to check to see if someone else has done this first before you try and redo it yourselves. Right. All those are, they're kind of hallmarks of collaboration, but they're especially really important in software because, right, the world of software and this amount of software that's available to you is so much wider, I think, than the resources you might have in another industry. The fact that we have the internet basically, and we have platforms like GitHub where people have shared a lot of their solutions and a lot of things that they developed, which I should also mention, that's a great place if you are developing software yourself. Get GitHub under your belt, because that's pretty much what everybody uses to share software and collaborate on. So I could really recommend trying to pick that up in addition to Food for Rhino if you are developing a grasshopper plugin. But I think, did that answer the question, JT? I know I answered what do you look for in a collaborator? Did I get the second part as well?
Yeah, kind of. But we got the names as GitHub and Food for Rhino. So are there any languages, particularly like C++, Python, that are more relevant in today's time that people should be learning? And I also want to address UI, UX, or product managing aspect of the tool.
Sure. Yeah. Okay. That's a good question. So maybe as far as languages that I'd really recommend, I mean, of course, everybody has their own preference about languages to that they prefer to work in. I mean, obviously, I'm really biased towards Python, and I think Neal is a little bit too, as you mentioned. But Python is a really great place to start, especially if you don't know any computer languages to start off with. Because honestly, once you get one computer languages under your belt, you realize that a lot of the concepts are, pretty universal across all the different languages. So I could really recommend Python as a great starting point because it's relatively easy to pick up compared to what we call the lower level languages like C that Energy Plus is written in. And so, so I could definitely recommend that as a good pathway of getting into this. And I think you also realize if you know Grasshopper or even if you know Excel, a lot of the same concepts that you learn in there form the basis of the programming languages that we use to develop software. And so there's really a continuum, I guess, if I had to say about that. So that would definitely be, I mean, the way to go about it. And as far as if you are trying to teach yourself a new language or teach yourself a new skill set, I think I mentioned this kind of earlier, but starting off with like a reference, like either a tutorial series, a class, or a book or something that like, you know, gives you at least a comprehensive overview of stuff, that's a good way to start. But you won't solidify the knowledge unless you start applying that on a project. So thinking of what projects and what problems you want to solve is a really important exercise. And that really is what will solidify a lot of the things that you're learning in your head. And then lastly, you're invariably going to get stuck at points working on that project. And like, yeah, Neal, you mentioned Stack Overflow. A lot of these forums that are great places to ask people, especially when you get stuck. And we should also say Unmet Hours, great forum for that Big Ladder maintains. It's a great forum for questions on Energy Plus and Open Studio. And yeah, I go there a lot.
Right. I feel like I should start taking notes or something.
Yeah, that's what I'm doing. I'm like getting so much validation on like Python and all of this stuff. So very helpful for me. And
So
Jaddy,
Kritika, yeah,
I
go
wonder
for
if
it.
I can just follow up on that a bit, because I also want to emphasize that I agree with Chris. Python is the right place for people to start, because it's used in some web applications. It's used in data science. It's used for computational stuff. It's like anything that you could touch, you know, Python's got some use for it. It's not always the best language for every application, but it's a good starting point. And then the other thing I'll mention is that I think that there's one tool that I think is not helpful to learn, and I think unfortunately a lot of people do learn it, and that's MATLAB, because I think most universities get students hooked early because they offer free licenses to students. So,
Right.
but it's not really useful in the, you know, real world.
Yeah.
So Kritika, at a student level, do you think you have those skills right now, or do you want to name some of the sources you're using to learn these things?
sure. I would say that I started taking Python classes. I took in my first semester, I took a C# class, and that's how I started getting into this whole side of making plugins, because I think we started using C# for doing plugins. And then I felt that I was stuck when I had to use and deal with a lot of data. And that started exposing me towards moving more into Python, and then learning this whole side of Python, which is like data science, and then using matplotlib for graphs and all of that. And if someone wants to go more into the machine learning side of things, then of course you have to know Python for that. So then again, that was one of the things. One more resource that I was using was learning JavaScript and more of this web platform development stuff personally, because as a student, you usually, let's say, have 1 or 1.5 months to finish a project and convey your prototype or your idea towards the final presentation. And I personally felt that making a web platform was the easiest way when you don't have to deal with packaging everything in a neat way, and you want it to be applicable to a lot of other people who probably are not so tech savvy with Rhino or Grasshopper, because in a design school, you have most people who are working with Rhino, but you also have people from like engineering or other backgrounds. So that was one of the motivations that made me learn JavaScript and more of the visualization side of things. And right now, I'm taking like both data science and visualization classes, and I feel that both of them will equally contribute to my thesis project, because you also should understand how to convey a story when you're just starting up. Otherwise, no one will want to listen to you. So you have to have like the strong side of visual aspect to it.
Right, completely agree. And now we have 15 minutes left. So I want to ask the attendees to put their questions in while we will move on to our big question. It's usually a controversial question where our panelists would be pretty frank. I'm hoping at least they are. So feel free to put your questions in the Q&A panel or in the chat. We will take them up in 5 to 7 minutes. So now the big question, after all this discussion about, you know, tool development and software development, it often comes to someone's mind who is about to start like a tool or make it as a business. So let's talk about, did you face any insecurity on what if my idea is like stolen by someone else and is used and their tool gets more popular? So is there some kind of licensing or copyright or patent that even an emerging professional can look into at this stage uh, without even having like a lot of resources?
Yeah. Well, I can speak to this. I like Chris. Most of our software is open source, which it implies some level of licensing. But I think there's some important concepts around copyright and licensing that are often kind of misunderstood. And so I think the first one is that any work that anyone does is automatically copyrighted, is implicitly copyrighted, even if it's doodling on a napkin or writing a software program. If you can protect it better by explicitly saying that this is copyrighted by a certain person. Now, if you do the work, it automatically belongs to you unless you're doing it paid for someone else. So like if you're building a little software tool at your company, then the default is the company will own that product. And so if you want to do something on the side, you probably need to make sure that you're very clear that this is my side project. It is not part of my work for this company. And then you can own that copyright. But there's no such thing as a piece of work that is not copyrighted. It's just a matter of how easy it is to trace it back to who owns that copyright. And then the piece about the license is the default is that there is no license, which means if you have something that you've made, no one has any permission to do anything with that unless you explicitly give it to them. And that's what a license is. And so the nice thing about software is that there's a lot of kind of standard licenses that you can choose from depending on what permissions you want people to allow. For open source, it's maybe easier because it's a lot more common. And for example, let's see, the licenses we use basically say that you can use our software any way you want. You just can't pretend that it's your software, and you can't say that I endorse it without me saying that I do. So that's pretty much that. So and then there's a wide range of options from there, but use a standard license. There's resources. I think there's like a findalicense.com or something that you can use. I can dig up the link for that.
Yeah, if you could provide that link in the chat, that might be really helpful for our attendees. Chris.
Yeah, I kind of just wanted to speak to what you said about like the fear that people have of someone else taking the idea. And I just want to say that more often than not, that fear, I think, ends up like creating more problems and hindering more innovation than it actually helps. And granted, like at a certain point, you may, you may want to do specific things to protect your stuff. But like, honestly, as a start, I would say like, like Neal said, making your software mostly open source is honestly, it tends to, bring more value to you ultimately at the end of the day, as long as you choose the right type of open source license for what you're trying to do. It oftentimes ends up helping you much more than trying to keep it all closed up and concealed. But to that point, there are, maybe, and this will maybe speak to what the link that Neal is finding right now. There are kind of like three main classes of software licenses, and pretty much all of them can somewhat fit into this thing. Of course, there are always like exceptions and differences in terms, but like generally, like it kind of helps to know these three categories of like, so there are proprietary licenses, which are right, everything's closed, you can't see my software, and they all tend to be a little bit different in that, but the basic idea is that you can't use the software usually unless you buy a license or something like that. So there's that. Then there are two really big important types of open source licenses. There are kind of MIT style licenses, which are called that way because it's like what it used to be all the way back in time when all the software was kind of developed by computer researchers at MIT. And it's a very permissive license, as we say, where pretty much like anyone can kind of take the software, change it, do whatever they want with it, distribute it how they like. It's very, very permissive. And maybe, there's some styles of that license that say you still have to give credit to the authors, which is always good to put in there. But generally speaking, right, MIT is great to use when you're trying to encourage other people to build on your work. right? Or, to contribute things back to you to make your software better, right? There are a lot of benefits that you get by keeping it open like that. And certainly, yeah, we use that a lot. We use MIT licenses for all the file formats that we make, all the things that we want people to really build on and use about our software. And then lastly, there's GPL open source licenses. And GPL, it's open source, right? So everyone can see the source code and they can see what's going on. But GPL is a very important clause to it, which says that, all right, you can take my GPL code and use it in your software, but then your software also has to be under a GPL open source license. And the nice thing about this is that it gives you a lot of protection from, let's say, a proprietary company coming in, taking your code and just copying it into their, proprietary software, not giving you any credit at all, right? It enforces them basically to share back whatever improvements they've made on your software with the community. And so honestly, I think probably most of the software that we produce at Ladybug Tools is actually under this GPL category. And it's very, very useful for things where you want everyone to be able to basically see the assumptions of the software, to contribute fixes if they find something wrong with it, or if they, if there's something to be improved with it. But you still want to protect yourself from like a proprietary company just like coming and taking it and and copying it into their own software without paying you or or giving you some sort of value in return. So yeah, we use all three of these licenses in Ladybug Tools, but honestly, yeah, probably the open source ones more often than but like we only have the tip of the iceberg is actually really closed source for the things that we sell. And honestly, if it was up to us, like if people were still willing to buy the software without us telling them to buy the license, we probably would find a way to keep it open too. But yeah, but that's generally, those three categories are really important. And, at least picking one of those three categories for the work that you're on, that's a really important process, I think, that you should go through before you go and publish your software, at least.
Right. Very informative. Kritika, I know are you using Creative Commons license?
Yeah,
Do you want to also address the process it usually takes? Like, is there a form or is there a site?
So there's generally like a basic website. I forgot the link, but you just have to go in and feed in information about who were the people involved in developing the software and who do you want to have, like all the names of your team members. So it's a pretty straightforward process. It takes like 5 minutes and then you have the license. We were contemplating between having an MIT license, but I think at that time we weren't sure on what direction we want to take with the tool. But generally, I would say as a student, all the tools that I've been developing are inclining towards having an MIT sort of license because you're usually looking for feedback and you want people to adopt it and see the potential of how it can be used in different formats in the industry. So that I think is the more favorable way to go if you're developing tools as a student. And I also want to address something on the protecting your idea question. Personally, I'm always looking for collaborators or people who are interested in building something with me. But I do understand that you should be cautious and publicize your idea in the right channels. So if you just have like a prototype, you shouldn't be the one going on a big platform and saying, hey, I have this. And once people start adopting it, there are tons of things which don't work. So you just have to be cautious and have like a smaller inner circle that gives you feedback on the first iteration that you probably develop, and then go on to these bigger channels to publicize your work or your idea, or however you want to take your work forward. So as a student, I would just be cautious on where exactly the channels I'm going to for asking for help or just getting feedback on my idea. But yeah, like Chris said, I don't feel that there is this feeling that someone will steal it, because if you have the idea, you know how to, or have an indication of what you need to accomplish it in most cases.
That's a really good thought. And I am hoping that this was very useful for everyone. So we do have one question by Jason. He is saying that I love Neal's initiative of making IBPSA-USA a certifying body of providing certifications to modelers like ASHRAE, BEMP, and regulating the building performance simulation process. My question is, how can EPSI members, especially college students, support this initiative? Neal, do you want to take up this question and Is it the correct explanation of what the certification committee is doing? Is it providing certification to modelers or more like the buildings?
Yeah, I guess, yeah. So a little bit more background on that committee is that it's fairly recent. And what we're trying to do is first get the landscape of what kind of certifications are out there already and what kind of requirements are required for different code or incentive programs, and to kind of compile that and then figure out where are the gaps in what are, like, so something like the ASHRAE BMP. Is there something that we can do to help supplement that, or make it better, or what is needed there? And so the committee is just exploring these. There's not a definitive direction like IBPSA-USA is going to make a separate certification or anything like that. There's certainly a need for some of the other cases like certifying software that just there's no one doing that right now, and it's kind of Wild West at the moment. But to answer the question about joining and participating, so any of IBPSA-USA's committees are, there's pretty much an open door policy. If you want to join a committee, you can join them. There's a committee website, and I'll post that as well in the chat. Hopefully everyone gets that. But it explains what committees there are, and some of them have applications to join. That's if those are the ones that have like voting members, but anyone can join as a guest too. So if you just contact, most of them have contact links as well. If you would just contact that person and express your interest in getting involved, then you'll be added to the mailing lists, and including this committee too, right, Jyoti, the EPSI committee. So
yeah, definitely. So I think we are at time, and this was a very informative session. So I thank you all for being the panelists. It was like we were really glad in EPSI that you all could be here and share your information, knowledge, and experience with all of us. And for the attendees, there is a poll that will appear on your screen. So do answer that. And with this, we thank you all again. Thank you for attending.
Thank you so
Thanks.
much.
Thanks
So
for
much
having
fun.
us.
yeah, thank you.